Hi, everyone. We are live. Welcome to another Memgraph community call. I hope you're all doing well. And it's definitely great to see you all in such a big number here today. I mean, it's an interesting topic, so it's no surprise, but yeah, we are waiting for the exciting presentation. Today, I'm joined with Vasilije Markovic. Vasilije is a founder and CEO of Cognee, an open source AI memory engine that turns unstructured data into dynamic and queryable knowledge. So before we begin, we have a chat here, so feel free to chat with each other or ask any questions you have for Vasilije during the presentation. And we'll have a short Q&A session at the end where Vasilije can answer all of your questions. We also have a post tab with some of the polls I posted, so feel free to check that out as well and cast your vote. So I think that's it for me for the introduction. I'll now let you, Vasilije, take the floor, and I'm really looking forward to the presentation.
Yeah, thank you, Matea. It's a pleasure to be there, and we've been working with the Memgraph team, so we've seen like the quality of work you do, and I'm super happy to be given a chance to talk to this audience
Yeah.
today. I'm Vasilije. I'm founder of Cognee, and I just went minimized. Now I'm not anymore, so I'm talking here.
Sorry.
Oh, that was a good one. I've been here building Cognee for around 2 years. My background's in big data, data engineering, and I've been working in a couple of companies in Berlin, building their data stacks, everything relation in the relational old school world. I was there even in the old times of the SQL servers and 40 minutes to 4 hours queries that would never end, to all the way to Redshift query and the fast inference that happened. Around 2 years ago, as I went back to uni, I figured that just using vector stores is not enough and we need something else. I built Cognee. We are now a team of 10, open source Python SDK. And I'm going to show you a small presentation on how we came to Cognee from the base problems we faced when we were building B2C applications. Then I'll show you a bit in our docs about the self-improving memory concepts, how we look at it, get your feedback. And if we get the time, I'll show you a small example of running Cognee and how easy it is to get started. So yeah, let's start. I'll share my screen, and we can definitely stop anywhere for questions where needed. So I think I need a slideshow, right? So hopefully you see it. So Cognee, right? So we are memory for system for AI agents. These numbers you see here, they've been going up a bit since now. I think we're at 100,000 library downloads, 7,000 GitHub stars or more. And more than, I think, 200, 300 projects using us based on our telemetry. And we are a Python SDK that allows you to solve this basic issue that a lot of, let's say, companies that are building with AI have. So imagine 4 out of 10 flights that you are observing not landing, right? And that's the current state of the RAG systems, right? So you can't if you ask a question, then 4 out of 10 times you get the wrong answer. You can't really do much with it because systems that need to deliver production grade responses to customers in production need to actually work 95% of the time. And this is the problem I faced when I started building back in the days where, I would ask LLM a question. And, if you take Leo here, who's some guy who likes German cars, advanced tech and high performance sports features, if he asks what kind of a car should he buy, pretty much the LLM, is going to be not really detailed in the answer. And that lack of detail in the answer is effectively, going to hurt us, and we definitely need more information about all kinds of vehicles and their comparison if you want to do a purchase. Just a generic enough answer won't do the trick. So with Cognee, you would get a more accurate and detailed answer. You would get the answer that Leo should buy Porsche Taycan with this size of battery, or ranging from size to size, with the range in kilometers, and then effectively you would get as much as you need to provide you the required information to make a decision. So we solve it and we change this approach of using these basic systems to solve these types of problems 9 out of 10 times. And how we do that, you can see the benchmarks on the left side. We did this hotpot QA and also compared to our competitors, Graffiti, Mem0. Graffiti is also doing a great job. There is Mem0, there is Lightrag, and a couple of other tools you can definitely try and check. And this was from Q2 2025, where we benchmarked our solution against them and saw that with this memory approach that we built, we can definitely get the accuracy up to the level that people can really rely on it. So how did we get to this accuracy, right? So the problem, as I went through it initially, is that the 4 out of 10 wrong answers is not going to get us anywhere. So Porsche Taycan as a car, general car suggestion is not detailed enough. It's maybe technically accurate, but not really practically accurate. So initially, when people started building these systems, they started with RAG system, right? And in this context, what a RAG system is, it's a system that allows you to load some data from in a batch, let's say a batch of PDFs, load it inside of a vector store, and then give access to this data to the LLM. LLM is going to do some type of a search over that database. This data is going to turn into embeddings, into this representation. And when we search for, let's say, a sport concept, when we are searching for Porsche Taycan, we might get Model X Sport Refresh, which is not really a sport car, but because it mentions this concept of sport, it's going to actually end up being used as a result, and we are going to end up with the wrong information. So that's what RAG did a lot. It mixes apples and oranges. It gives you the wrong fruit. When you need a refreshing fruit, you might get something else. And the problem with RAG was that it really created a lot of these inaccurate answers all over the place, because simply it did not understand what your context is. It didn't understand that the sport needs to represent a certain type of a car that does things in a bit of a different way versus just having sport in its name. And how does the flow usually work? I'm sure you've seen it this all, right? If you try to actually build a RAG system, you take some data sources, PDFs, HTML databases, you ingest and chunk, might use LangChain for that. Back in the early days, you stored it in Pinecone. It was the hot kid on the block a year ago. Now there is many other players in that space. And you definitely create these embeddings in Pinecone, but then when you need it, you retrieve the data from it to give it to the LLM so LLM can respond to you. Relatively simple flow. Everyone was building one a year and a half ago. And at this point now, it feels like it's definitely surpassed a bit. So here you see, let's say, some positioning of these embeddings that would be positioned in a space together around. And you see that here we would have some information about Cybertruck and Tesla's trucks chunked and stored in different parts of this embedding space. And the things that are semantically more similar to each other will be in the space closer to each other, and things that are further away will be farther away from each other. So pros, this system is Pythonic, works better than the LLMs, LangChain, and the others, but it only provides you this vector search. If you want to reindex, so load updated data, it's going to be very slow. You need to replace the whole setup there. And it's not going to work ideally for any type of a large volume of data. We've seen people load data for days from larger companies with microservices running and sending requests, so not to overload the API. So all of this was definitely one of the bottlenecks of these types of systems. So we tried it. We did this DB load. We split the data into chunks. We passed them to the context, and then it failed. So I built some type of a B2C app initially before I even came up with the idea of Cognee, to personalize the answers for each individual user, where we would create a dynamic UI. So you would get like a UI in the app that would generate for yourself with the buttons that are really personal to you based on your interactions with the UI, but also with the memory component it had inside. And I really couldn't get it to work. Like, I could get it to work in a very ugly way with metadata management on the vector side. And I felt like, okay, this is really not production ready, considering that it failed for me in a way that I didn't expect it to. Like, I come from this big data systems where you could process. I mean, in some tables we had like 22 million rows of data in one day, right? And here I would end up with like 50 megabytes completely messing up the things, or not being able to handle update logic, or things, basic asset functionality was missing. So I was figuring like we probably need to move past this and implement it in a better way. So since my B2C app was a commercial failure and I definitely didn't really know how to build a B2C app, I figured to go back to what I knew more about, and that was building the data systems, right? So in the next step, right, what I came up with an idea as I went back to uni and tried to figure out, how can we improve this. I figured, how about we add some type of knowledge ingestion and management system on top. So I figured, let's do the embeddings, but let's also do the triplet of the graph extraction on top and link these two all the time. So if I could do that, I could effectively get a representation of all the entities that are in the embedding space, but have a more granular control over the connections and relationships, since the graph systems provide that. I was basing this on long-term, short-term memory paper from Atkins and Schifrin in 1968. I kind of went back, as I went and studied for these exams, I thought like, oh, this would be amazing to implement. I did. I wrote a blog post about it and how it could be done, and then Princeton came out with the koala paper like 5-6 days later. So that's the only probably time in my life I beat Princeton at something, but definitely my quality of my blog post was much lower than what these guys had. But as I kind of moved forward with this idea, it kind of started taking more and more shape, right? So I figured I could build this in Python. I could use Neo4j. I could use Memgraph. I could use other types of databases to build this layer, and then kind of just represent the data in the embeddings instead of getting stuck with the approach of just using the pure vector stores. Then with that new type of a data layer, the LLMs could retrieve the information from the vector store and then and the graph store, and just pass it to the system so it can actually reason and answer the relevant questions that the user might have. So how does this flow work, like practically, right? So you would usually take some PDFs, so I don't know, HTML, database, whatever you had, you would ingest and chunk data with LangChain, you would create the embeddings, you would store this via structured outputs to the graph database using pedantic structures with instructor, or with just the JSON parameter in the API. Back when I started this, there was no structured output, so I had to say please many times to get this to work. And one run on a 5 PDFs would cost me like $300. Luckily, I had some credits, so I paid from my pocket. But it wasn't really something that looked like it's going to work initially. But then as the systems improved, as we got the structured outputs, as things got clearer and better, then effectively these systems became a bit more performant. So let's say we have this structured outputs of these graph representations, we have the embeddings, all of that synced. Then we do retrieval, and then we surface to the graph, get some information and connections, and LLM is already giving you a better answer. So this is something that we effectively done, in the first iteration of the product, and we built it as a set of Docker images, sometimes end of last year, and then the first end of 2 years ago almost, and then end of beginning of last year, we had the first release of the Python SDK that could do this for you, which you could just install and set up. So it worked, it was fine, but we had like this representation and connections. Finally, we could answer and get the right flow and the connections between the elements in the files were finally clearer and more accurate. Pros of this approach is that we got the graph structure that improved the accuracy. We could model the data with pedantic, but what the cons were is this couldn't really be parallelized. It was slow. If you change the SDK on the vector store or some parameters, things would break. You couldn't really add custom logic to it. It was just like how we imagine things to work, and we definitely didn't want to kind of stay that, because we saw that people are coming with many different questions and many different use cases that definitely our solution wouldn't really solve out of the box, right? So that's the big learning there, that it worked, but it didn't work good enough. And then, we didn't want to end up in some LangChain type problem where we couldn't really be used in production systems, and we really wanted to work towards that. So we decided to move from RAG to memory. We decided to really change the set of things that we thought are, breaking the whole memory narrative, and that is one of them is ontology. So ontology, for those who don't know, that can represent some type of rules or rule relationships that you can add to any system, manage it, connect it, control it, and have an understanding of what happens where. We just published a case study with a big bank where they had different departments in different states that needed to access different card interest rates, and just doing that with RAG wouldn't get you accurate enough. So you need an ontology, you need some type of representation that in Alabama the interest rate is 5% for a Sapphire card, whereas in New York the interest rate is 7%, and that like cash bonus is $5 versus I don't know, Wyoming, where it's 15. So all of these rules can be modeled and mapped and then connected to the data you ingest into the system from less structured sources. So you always have this basic truth that you can use. So we added ontology, we added the RDF loading, we added loading from other places, made it nice and abstract, and we definitely saw improvement. Second thing we added is the state representation. So being able to effectively load and store the data inside of the as it's being processed to the S3 buckets, to the flat file databases that can be stored on any device, that would enable people to locally use Cognee, but also to manage it on the cloud. And we've seen a lot of improvements and changes to the system to enable this use case. Composability is a big one. For us, that meant designing effectively a data pipeline that's composed of a set of tasks that can be tied in together, that we can custom write and build. So task can be a search task to the web that gets some data from Google, that can, or the task that can parse up certain PDF, extracting just tables with certain formulas and ignoring others, anything you really need. And you could easily build that as a set of Python functions that just pass the data objects between themselves. And finally, reasoning. So for us, an important piece we realized is no one really wants to use Cypher. It's fun in games, but you want to have a layer of abstraction above it so that you can interact with the system still in the natural language. And we want to give you the context or the solution, depending on how you do the settings. But we build this retriever logic that builds a set of layers of retrieval that can be optimized and used by our system in order to actually give you a better quality of the outputs out of the box. So we support anything from searching about time-related data to, just getting the graph elements, vector embeddings. You can do traditional RAG if you want, and then these, chain of thought type approaches where we kind of reason over the graph. And all of these let us really improve the quality of the outputs and get much farther with the system than we would have otherwise. So these were the lessons mid-year for us in terms of what to do and implement. And we did that, right? We implemented an automated knowledge ingestion and management system with reasoning capabilities. So we kind of went one step further. And to get these reasoning capabilities evaluated, we added a whole evaluation framework to the end of it. We used deep-eval, pretty clunky Python framework that you can use and define your own metrics and solutions, but works for us. And we definitely ran it many thousand times to just see how well any type of a change to our system is improving or reducing the quality of the outputs. So that's the base set of the things we've done and how far we got. And as a flow now, we can just pull data from any data source. We can use DLT, which is a Python library that allows you to ingest from 30 plus data sources, move the data inside of our system, create the embeddings, use our tasks and pipelines to process the data, and then have a store in a vector and graph store, allow the retrieval of the data, do the graph enrichment and get the LLM response that we really need. So this system definitely works much better than what we had before. It's Pythonic, it's modular, it's parallelizable. The cons are a low-level API still quite hard to use. We worked the whole month of August to simplify it and improve our docs. And we definitely didn't have like good user isolation, right? So you couldn't really do anything for different users with a hard isolation where data could be leaked from one user to another, which would not be allowed. And you could definitely not do much custom retrieval that in a way you wanted to build it, right? So to solve that, we built pretty much a next iteration of the system where we use the file stores as stores of truth, use these Kuzu and LensDB as the databases, and also Memgraph as an option when you need more server capability, or Quadrant, or whoever provides, let's say, a better interface that way. And we allowed you to isolate per user both the graph and the vector store. We added graph enrichment, which is called Memify now, a new pipeline that goes and adds these memory components and connects the dots in a different way. And then we packaged all of that together so it can be deployed and run anywhere. So right now, I think it takes around 40 minutes with our distributed system to process a gigabyte of data. And we can definitely do that on more than 100 containers we are running now. So I think with 1,000 containers, we're going to end up with doing much better. And then it's just about the capabilities of the databases to handle the ingestion. In terms of the number of let's say, people using us, we're seeing growth almost twofold month over month as we are getting more mature and the system's maturing. We are now on 0.3 version, and then it's gonna take us a bit until we get to 1.0, but we're definitely working towards it. So the pros of this approach is we have some versioning. There is S3 buckets that everyone's using and Delta data lakes. We have serverless. Cons are mobile support is not there. JavaScript is missing. And then real scalability, like a terabyte of data, is still not fully there. So we're working on the mobile SDK. We're working on TypeScript support coming out in this quarter. And we hope to be able to extend most of the use cases right there. So yeah, a couple of other things we've built. This evaluation module I mentioned, we've built a hyperparameter optimization tool. I can definitely link an archive. I think this QR code expired a while ago, so I'll leave you a link in the conversation there if you want to read that. And that paper is showing also a lot of evaluation results and the methodology we use to get to them. And then we have also a lot of custom tasks. We have a community challenge right now where we have like 10, 15 tasks people are building at any given point and trying to help us kind of get to the next stage. So let's check it out. This is the GitHub repository. It's open source. So if you just go to Topoteratis Cognee, you'll find it. And then we have a community on Discord if you want to join and ask us any questions. I'll just leave this here for a few seconds, and then I'll show you the GitHub repo and then maybe go quickly through the way of getting started and then kind of seeing what can we do to move forward. So, oh yeah, we got the link here from Hande, who's our growth engineer. So she's definitely yeah, slides I can share for sure. I'll post the link right now. Give me a second. Anyone with the link, is a comment there. Okay, great. Here are the slides. And then, yeah, let me share my screen again. How exactly does reasoning work against graph nodes and relations? We will need to pull in our data scientists to explain this one more in detail, but we can also check our docs. I think I'm the wrong person to ask since I didn't implement it, but we can definitely get some insights. Maybe Hande can check with him before we wrap this session up and get you that answer. So GitHub. So this is Cognee, and then Cognee as a Python library is relatively easy to use. So I'll just kind of quickly guide you through what you can do, right? So you can effectively have this few set of commands where you can add any type of string or a list of strings or files. If you want to do a file, you need to preface it with file two dots slash slash. Then you can just run Cognify. Cognify can be run on as a blank statement, but you can also specify what do you really want to run it on, which can be data sets, which can be groups of data sets which represent a group of several files. Memify is our custom memory set of memory algorithms that go and clean up the data that hasn't been accessed in a while, connect the dots in different places, do more things there. And then Cognee.search allows you to actually search through the database and get the default graph completion tasks. So in terms of how that actually would look like, I'll try to run this. I just synced this before this call, so I hope it works. But let's see, Python. So then we have this simple node set example that I could maybe run. Oh, damn. I think I can try doing examples and then Python. Sorry, I created a lot of fresh setups recently. I was testing something, so let's see if this works. I don't know if we even have the API keys here, and I cannot go and check since someone's going to copy this. Let's hope it works. So what you do is you set up your LLM API key, which is effectively OpenAI API key. Yeah, I don't have an API key in this one called cleanup. Maybe I have something here that can run. Examples, and then we have so let's see if this one works. So what we do here is we're taking some tree texts. We are defining node set, which is something like a schema in the database. We are adding them separately, so each of these can then be searched independently. These are, for one user, you can have multiple node sets, and you can isolate your data in that way. It's a soft isolation. And then after that, you can effectively search per node set or and visualize the graph you created. So while this is taking a while, I'm going to show you another thing. Okay, so it's finished. And we got some artifacts. We got the graph visualization that I can open in Finder and then see it here. Oh, here we go. So all of the text that we have here in the system. So AI is revolutionizing financial services, advances in AI are enabling smarter systems, tech startups have seen significant growth in recent years. We can see that each of these is now stored in a text chunk effectively, that it is getting connected. It has a concept field and it's belonging to a certain node set, which I suppose is this, but maybe it's getting a bit buggy today. So yeah, then you can definitely see that medtech, fintech, so those were our isolation points are working. So yeah, this is how this would look like as a visual representation. And then when you search for it, you would get the results pretty much out of the box. So if I comment this one out, and maybe we can try and run it, so see how it works. And I can say results equals await Cognee.search what is in data, and then I'll print the results. So let's rerun this again. Yeah, the data includes relationship descriptions of nodes related to AI impacts on financial services, fraud detection, medtech starts, and digital health and medical devices. It outlines how AI is used in fraud detection and many other things. So this type of functionality is, the typical SDK piece, and that's something that you can customize. You can build all these steps yourself. The Cognify, Add, and search are the defaults we provide, but you can build your own custom pipelines. So if you want to check how to do that, you should go to our architecture and see about the building blocks of Cognee that would allow you to actually move to custom pipelines that you want to build. And then finally, we have something that we launched recently. Someone asked about enterprise. So we are relatively small startup, right? That effectively allows you to build this memory and self-host it and manage it mostly yourself. So we are not moving that much towards enterprise, but what we wanted to do is to build something for developers to effectively be able to run Cognee locally and also play around with it on the cloud. So this is our new release. You can just add custom data to Cognee via UI. You can create Python notebooks, and then you can effectively search this data and handle whatever you need. There is also a coding inspired, like coding copilot inspired tutorial that would help you build, let's say, better representation of your code. Another thing here, you can run this with Cognee -UI command, and you can run this whole UI locally too. And if you don't want to pay for the service, you don't really need to. You can just do it yourself. And if you want to have it in production and get your API keys and get the access to the system, you can just pretty much sync the data with one command, and the data will be there on the cloud. So yeah, you can see here some API keys you can generate, and you can get the API access to this service with all of your data exposed, so you can search it and use it. So that's the general kind of overview of things, and maybe it's a bit of time to leave for some questions and chat with you guys on the things you were curious about.
Thank you, Vasilije. This was great. I love hearing the story about your product and how it started and how it's developing currently. We have some questions from the audience, so we can get started with this because I can see there are a few of those. So we can maybe do the first question. Let me go to the Q&A tab. The first question is, how do you save PDFs and HTML in a graph database?
So what we do is we have this add command that allows you to have any custom ingestion flow built into it. So it's also like you can define any custom flow there that you'd like, and then the typical way you want to read these files. And then we read them, we process them, we create chunks out of them, and then we send that to the LLM saying like, hey, this is a text blob of text. Can you create a graph representation out of this for me based on this blob of text and based on a system prompt that we built in-house? And then the LLM is going to give us the representation. If the data is deterministic, meaning it's a relational database or something like that, then we can take that data, we can put it inside of another type of processing system in this add command, and then it's going to just populate the graph one-to-one and just do the physical translation. And that effectively lets us use the more deterministic systems and then feed this non-deterministic LLM inspired data on top, so we can kind of have a bit more accuracy and trust inside of the data. And last thing, we have this ontology concept. So these ontologies can be defined by hand, and they're these traditional semantic web concepts that we can also ingest, and then we merge that with this LLM generated data, thus grounding the data and giving it more accuracy. So you can think of each of these steps as one layer that kind of adds on top, and then we add more logic to really make it a bit more secure, because LLMs do generate a lot of noise.
Yeah, and if you're interested specifically in how Cognee works with Memgraph, we have an integration, And we built an example notebook, so you can check it out with this link that I just sent in chat and see for yourself how it works and how it's integrated. Okay, great. We have another question from the same user. So the question is ontology part auto-generated from the data or manually implemented?
So what's in open source now is the manual ontologies you can load. We have the auto generation on our end, which is not a part of the open source product that we pretty much sell to people because, hey, everyone's interested in that.
Okay, and can you please tell us about the embeddings a bit? Which type of embeddings does Cognee use and what can we use?
So I asked my data scientists, like, this question comes up a lot, like what kind of embeddings are the best embeddings to use? His answer is like, just use the text large OpenAI embeddings. It doesn't really matter, right? So effectively, since we rely, most of these systems, in RAG times really vary based on the embeddings. But because we add the graph on top, like the variability of the different approaches to the embeddings is reduced a lot compared to the other systems. So I would say, yeah, OpenAI's embeddings work fine out of the box. We've tried a couple of others. We haven't seen any type of a significant improvement that would vouch for so that we would vouch for those.
Yeah. And one more question that I see often when it comes to these topics. So how are you dealing with the entity disambiguation? How are you making sure different references to the same entity are stored into the same node?
Yeah, it's a good question. So some of the ways we've seen this is by running multiple runs and then deduplicating effectively the entities, and in case they appear in n runs out of 10 runs, if it's 8 out of 10, then probably these entities exist, and you're kind of reducing the margin of error there. It gets expensive, but it gets more accurate. The other one is effectively we did a lot on getting the references from the source documents and then kind of cross-checking, including always that, so you can have the whole path in the tree. The deduplication logic we also have in the system helps. So I would say it's a combination of, let's say, deterministic engineering approaches plus then running and asking the LLM multiple times. Another approach I've seen works quite well is you ask a different LLM about one other LLM, so that it cannot be biased by the previous answers it provided. So you go to Gemini, and then you check like, hey, does this make sense or not? Like that could help also in terms of like giving you the correct answer.
Yeah, and we have another similar question. I guess it's the same answer. How do you manage graph updates, existing graph updates without having duplicate nodes?
Yeah, so if we have an existing graph, we go and we delete the chunk and all the nodes associated to it and that document. So we kind of clean that whole thing and then we replace. There is no good way to do incremental updates on unstructured data, because let's say we want to do it chunk by chunk by chunk by chunk. Then if the chunk 74 changes, until that point we would keep everything the same, but then the chunk 75 and further would change, and only then we would do the delta incremental update of the chunks below. But what if the size of the chunk changes? Then in that case, like the whole thing you need to kind of throw away. So the engineering that is possible, but it's just kind of expensive and clunky, and it's there is a lot of moving details. So we just decided like, okay, we'll just delete this and then replace it, and we have the delete logic implemented. We are now trying to generalize more. The delete logic works well with Cognify, but we want to make it a bit broader, and that is something that should be out in a week or so.
Yeah, makes sense. And I can see that you have some contributions here, please. So users are asking, can we contribute to this project?
Yeah, definitely you're welcome to. So go to our GitHub repo. We have some open issues that definitely I think we'll open a couple more like today, tomorrow, that you can definitely check out. I would suggest first try running the pipeline. have a look at it. Try building a custom pipelines. Come and ask us questions on Discord. We're happy to help. And then if you want to contribute, you're more than welcome. We have these contribution challenges. We also send swag like T-shirts and everything in between. So happy to get you warm clothed for the winter.
Yeah, as with any open source, I think contributions are always more than welcome.
Exactly.
Yeah, we have a bit more product questions. So is there user isolation as of now?
Yeah, so we have user isolation on database level. So you define, you need to enable multi-tenancy. And then once you do, you have like main tenant, you have subtenants, you have all of the levers of control. Go to docs.cognee.ai. There is a whole tutorial on how to do this. It's been really updated recently, and definitely you will just be able to keep the graph separate per user.
Yeah, and another one would be, how do you work with multi-tenant or unknown data?
So I don't know how to work with unknown data because what I don't know, I cannot understand, right? So, but effectively, multi-tenancy in this context, like isolating per user, is something we saw as a pattern that works. You can then send data to different users from Cognee easily and just never touch the wrong user, and also manage the permissions tenant has and the permissions other users have, and change those programmatically via the API, but also pretty much in the code. And then the unknown data, I'm not really sure. The unknown data is usually not an issue because people don't really just send any type of data to us. They send the data that they need processed. They know why they're processing it, and yeah, effectively, we can isolate usually what's happening.
Yeah. And we have one existential crisis question. So how to trust on LLM graph generation?
Yeah, I mean, I think it's a matter of a question: is the glass half full or is it the half empty one? So these types of systems got very big, like 15 years ago, semantic web. Then they died out. Why did they die out? Because you needed to manually keep this in check. And I sometimes would trust the LLM more than I would trust my fellow human to manage, some set of data that like is boring and not really interesting. And that's what I would say. How can you trust people, right? To manage your databases the same way I think we can trust LLMs. There is going to be mistakes. There is going to be things we need to improve, and things we need to get to an accurate state. But it's the best thing we have right now.
Yeah, and if you're unsure, I think it's always good to have a human in the loop if you have really sensitive data. So if you don't trust LLM, you have to have a human in the loop, I guess.
Yeah, and then even human will make a mistake. So, but yeah,
Yeah.
I would say definitely try the Memgraph integration. Try loading the data. Try seeing how that works for you. And then, if you're unhappy, you're unhappy. We can change that, but we've seen a lot of people able to use this in production, both from Matea's side and my side, and I think this is only going to come up.
Yeah, exactly. Another question we have is regarding verifying the data. So once we have the knowledge graph created, how can we verify that it took all the information from documentation that we provided?
Yeah, so the evaluation framework on the end, what you do is you define a set of question answer pairs, and these would be, your domain questions on the expected answers you would get from this data. So you say, I don't know, it's a financial data. What was the revenue for the last year? What was the number of shoes sold? If it's a shoe company, how many people were working in a shoe company? And you would define all these questions. You would say, like, I expect the answer to be 400 people was employed, revenue was 1 million, and then the best shoes we made were like Boro sneaker shoes, because why not? And then you end up with like a set of questions and answers, and then you would run Cognee and put the data in Cognee, and then you would ask all these questions, try to measure the results of these answers. If you have like 20, 30, you could get a feeling of what works, what doesn't, and what worked well, and then you can just iterate.
Oh, thank you. And is it mandatory that Cognee needs to use the knowledge graph created by it to be used for agentic memory, or knowledge graphs can be done with other options?
Yeah, you can do knowledge graph by yourself and just write a custom add function that will just bring your knowledge graph into Cognee and then enrich it with Cognee's logic. So it's not really prohibited in any way. We haven't gotten to many of these cases yet, so we didn't build an integration for it. If you want to contribute and help us, we are more than happy to extend the functionality there.
Yeah, I think we ran out of questions. We've had quite a few here, so if anybody has something else to ask, feel free to do so right now. But yeah, based on the questions and the engagement, I think this was a really interesting topic for people, and I can see that they are interested in your product as well. Okay, we have more questions coming in. So automatic ontology generation will require PII data to be shared on Cognate Cloud and cannot be kept local. Is that correct?
No, it's not. So we have on-prem deployment. So if we have a contract with anyone, we would give them all the access to the automatic ontology generation code, and they can just run it on their own site. So we definitely don't prohibit anyone from using that. And they can use it in isolation of their own cloud, their own LLM, their hosting, or whatever they need. So Cognee can, what you see on the cloud is pretty much open source Cognee. We haven't added any proprietary stuff to it because simply we wanted to, show you what you can do with the base system. And Cognee Cloud is just there for people to get a feeling, build some first prototypes, play with that, and then for us also to learn what's interesting and important to them. And we are definitely releasing, Cognee Cloud with more processing power and everything down the line as the interest grows.
Yeah, thank you, Vasilije, for all of your answers. I think that's it for the questions so far. We'll see if anybody asks anything else. But yeah, if that's it from the questions, this was a really great presentation. So thank you again for presenting. Oh, can you also please comment on Memgraph Cognate integration? Yeah, so I sent already the link to the integration, so you can check it out for yourself. But maybe Vasilije, if you have some comments on that.
Yeah, so Memgraph and Cognee integration is done in such a way that Memgraph is added as a community adapter to Cognee, where you just need one line of code to register the community adapter and then start using it. You can go to Cognee community repo, you'll see Memgraph there. There is a whole example on how to use it. You can effectively just get the Cognee running, install the Python SDK, then install the Memgraph SDK, Cognee Memgraph SDK, and then just use the tool. If you have any other questions, I would suggest coming to our Discord, or you have difficulty setting it up. I think it should be working easily out of the box, but we are more than happy to support, and we maintain and upgrade this package regularly.
Yeah, likewise, Memgraph also has a Discord community, so feel free to join there as well. And once you have your data created with Cognate in Memgraph, you can also explore some different graph algorithms you can run on top of your data and play around with that as well. So yeah, feel free to check it out and give us feedback, let us know what you think, and if there's something that we can improve, of course. I hope I didn't miss any questions. I think I didn't. So yeah, thank you again for the 10th time. I'm sure there's another question coming in as I'm saying that. But yeah, I hope everybody enjoyed the presentation as much as I did. We'll have the recording available on Memgraph's on demand page. I'll just send a link to that in chat as well. So it will be available in a few days. So keep an eye on there if you missed anything or if you'd like to rewatch everything. So yeah, thank you again. Thank you for everybody that joined. I hope everybody has a great rest of the day. And we're going to see you on our next community call, hopefully. Have a great day, everybody. Bye.